All right, I'll just explain what we're doing. We're going to be going over a subject called 10 Things I Like About Astronomy and how you can like them too. I really have about 1,000 things, but I'll try and stop at 10 because astronomers tend to talk too much. I'm Jim Goetz from the KW Astronomy Club. We are the center, Kitchener-Waterloo Centre of the Royal Astronomical Society of Canada. Our 5,000 members across Canada invite everyone to learn about the night sky. You can attend any of our regular online meetings and events when we have them. Our next meeting is this coming Friday at 7 o'clock. I'll be talking about my 2019 visit to the Jet Propulsion Laboratories in Pasadena. It's important to know this because I got to see the Perseverance rover that's on its way to Mars and will land there next month. I saw it being built. So if you attend the lecture when it lands on Mars, you can be all smug to your friends by saying, "Yeah, I met the guy who saw it," stuff like that. Now, the contact information I've sent to Verda, and if you want, she'll just send it out. It gives you all the particulars on anything you want to do with the club. You don't have to join. We're just happy to have anybody come by. Basically, I'm just going to go on with the presentation. Astronomy is the study of celestial objects and phenomena, which is blah, 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 blah to me. My definition is really simple. If you can see the sun, you're doing astronomy. If you can show somebody the sun, you're teaching astronomy. And the rest is all just details. And it's not that hard. It really isn't. You just have to learn. The best thing you can do with astronomy is get with people that do it, hang out with them. And they're sad and lonely people. They socialize in the dark in dark places. So they're really, really lonely. So you can go up to them and go, "What are you looking at?" And they'll spend the rest of the night trying to convince you to look through everything in their telescope. I'm the talker in the club. I do the communications. So it gives me the right or the privilege to talk endlessly about what I'm interested in. I'm going to go over 10 things that I like about astronomy, and I'm going to do them in a certain order. If you have any questions, as soon as I finish talking about one of them, just raise your hand or just blurt it out or just have a general discussion. I like to keep a freewheeling thing, very unstructured. But the first thing I'm going to talk about is our brightest star, which is the sun. To understand the sun and how it works is to understand how stars work. So basically, half of the astronomical knowledge is based on how a star works. And the more you learn about it, the more of a social pariah will be with everybody because you don't have to know very much to know just how amazing a star really is. Star forms from the most abundant element in the universe is hydrogen, and it's probably about 90% because it's the basic bottom line atom. It's just one electron, one proton. So because it's so simple, it makes up such a vast quantity of the universe. And what all a star is hydrogen starts to get attracted to other hydrogen atoms, and over a long period of time, it all starts to attract and attract and attract. And the more the atoms attract each other, the denser they become. It just forms into a cloud, and then it forms into a really solid core. And when it reaches enough pressure, it fuses, which is an atomic reaction, a nuclear reaction. And basically all it does is it fuses into hydrogen and energy. It actually spits off a neutrino and this sort of stuff, but really it just spits off, turns into hydrogen and energy. No, sorry, helium and energy. When the gas becomes dense enough, it fuses. The sun is so big that the energy created in its core takes 75,000 years to get to the surface. And when it does, it boils up into a sunspot. And if you look at the little dark patch here, that's a sunspot. Now, what's really cool about sunspots is this is the interior of the sun. It's a lot more complicated than you think. NASA and other countries in the world have space telescopes that just stare at the sun all the time. And they're always looking at it. They just launched one last week that's just going to get as close to the sun as anything ever has. And its job is just to stare at the sun for 7 years. So this is science that's really, it's always progressing. We're in the part of an 11-year solar cycle because the sun waxes and wanes when it comes to sunspots. So we've just gone through a very dry period when it comes to sunspots. And so we've started to see the first one show up, and our moon goddess, she'll be speaking at the meeting on Friday. She was out yesterday looking at the sun, and she saw her first sunspot in a while. So all they are is storms on the sun. You can see them through a regular telescope if you have the right filter. And if you have a regular solar scope, you see it in a different frequency. So basically with my telescope with a standard filter, I will see sunspots very well. But with a hydrogen alpha telescope, which the club has a couple of, you can't see the sunspots, but you can see the solar flares off the surface and, you know, all that sort of stuff. And it's quite extraordinary to see. So if you ever get invited out to see it, or you hear somebody doing solar observations, definitely go out and see it, because it's stunning. It really is, when you realize it's a lot more complicated than people think it is. All right, the next thing is the moon. Now, we've all seen the moon. We've all seen a full moon and everything like that, but really, you've never really seen the moon until you've seen it through a telescope. And I can always tell when somebody's looking through a telescope and sees the moon for the first time, because they always say exactly the same thing. Oh, wow. I don't care what language you speak, where you're from in the world, you always say, oh, wow, because it is an extraordinary. What's really, really interesting is just the idea that you're actually looking at the sun for the first time is a moment you remember for the rest of your life. And most of these things that I talk about this evening are that. And that's why I like to talk about them. The full moon is not the best time to observe the moon. It's actually too bright. And because you see so much of it and it's so bright, you don't really see any detail. The reason why we can't see any man-made objects on the moon is because it's too bright. It's washed out by other features and just the amount of light that you have to, that's on the surface of the moon. So I actually put a filter on it and dim it down a bit. The best time to see the moon is every other time. It's pretty simple. This is a quarter moon. It's in its first quarter, and eventually more light will go across every night you'll see a different, the moon will actually get brighter and brighter and brighter as it slows around. Can you guys see my marker on here? Now what you do is, on the first phase of the moon, you get a new moon, which is completely dark. And the next night you get a thin sliver of the moon here. And the next night you get a little bit more and a little bit more. And over the course of about a week or 10 days, it actually turns to a full moon. But during that time, the best place to observe the moon is along the terminator, which is the line between light and dark, because that is where all the shadows are. And the shadows are the things that allow you to see the features on the moon in 3D. And if you can get, well, I'll just show you. You can see the dark area and the light area here, and how the shadows give you the 3D effect. And if any telescope worth its salt with a little bit of magnification should be able to give you a picture like this. The moon is an extraordinary place. And on when you're observing it, there are features on the moon, like there's a 50-kilometer wall that just forms a straight line on the moon. You wouldn't expect it to be there, but it's 50 kilometers long. But you can only see it one day a month, because that's when the terminator hits it. And so looking at the full moon, you're kind of cheating yourself because you don't really see everything. But if you get out every night and you look at the features on the moon, then you can really, really start to see the features on it. Now, there's something about a crater, you'll always notice they're round. But meteors come in, meteors and rocks from space hit the moon at all angles. So why are all the craters round? Because if you have something coming in at a slight angle, it'll leave a trench mark, right? It should leave a long, narrow oval groove, right? Anybody have any idea? The rocks come from space, do not hit the surface of the moon and then just go up like a puff of dust. They explode. Doesn't matter what angle the rock comes in from space, as soon as it hits the moon, there's an explosion, and it's the explosion that forms the crater. And the debris goes up, and then it falls back, and that's why in the center of the crater, you've got a pile of dirt. Now, the reason why that's important is because the Curiosity rover on Mars was landed outside a crater that had a large pile of debris in the middle of the crater. And that means that instead of going in onto Mars and actually digging stuff up and everything, all they have to do is drive up the side and they get a different sample of rock samples all the time. So people with Jet Propulsion Laboratory are geniuses. So they're actually, that's the mission of Curiosity right now, is they're going up this crater, up the Gale crater, and they're just going through debris, looking at stuff that's already ripped up and torn. Kind of neat, eh? There are 1 trillion craters on Mars, on the moon, that are bigger than a meter. So don't ask me to name any. I got this picture, and then I had to go to the moon goddess to get her to tell me what it was. She's quite an extraordinary woman. She spent the first year in the club with me nagging her to get her to talk. And when she talked, she wouldn't shut up. We like her for that. So, third thing that I find fascinating about the universe is Jupiter. And we've all seen this picture before. It's a gas giant. It's so big that it's almost a star. We know all about the bands and the Great Red Spot down here. And the Great Red Spot is a storm that's been rotating for 400 years. And the reason why we know it's been rotating for 400 years is we've only been looking at it for 400 years. We have no idea how long it's been going. And it just rotates around and it goes along this. And these are all clouds of gas. And we have no idea what they are. A lot of them are just hydrogen. The core of Jupiter is so dense that it's hydrogen compressed so tightly that it takes on the property of metal. So it's called liquid metallic hydrogen, which just lets you know that what I think is sexy. It's also the planet that ate my favorite spacecraft. The moment you see Jupiter for the first time in a telescope is the moment you'll remember all your life. An ongoing theme here, but it is an extraordinary thing to see. The bands are pale red, and through my telescope, you can actually see the colors. The colors would be a little less colorful. They're a little duller, but on a clear night, you do get to see the bands, even though that other picture I showed you with the telescope is my telescope. So it doesn't take much to really be thrilled with Jupiter. There are four big moons of Jupiter, and they're Io, Callisto, Europa, and Ganymede, and they're all different. Io is really close to Jupiter, and it's a really small moon, and it's flexed by Jupiter's gravity so much that its surface rises and falls 60 meters every time it orbits. So it's constantly rising and falling. And because of that much turmoil going on in the actual rock, it's also the most volcanic moon in our solar system. And there are pictures of it, and it looks like a pizza. It spews out sulfur plumes 100 kilometers in the sky. Callisto, I don't know much about. It's always the It's the most farthest out of any of the 4 Galilean moons. Ganymede is a chunk of rock, but Europa is quite extraordinary because it's an ice moon. It's covered with ice, and they figured there's liquid water underneath it. And the water is as salty as the Dead Sea, but they're working on a probe. They can land on its surface, melt down through, and then swim around inside. Now, these moons rotate on their orbit in this line. So whenever you look at it, these moons will always be in different spots. So every night I go out, there'll be 3 on one side and 1 on the other, or 3 on one side and 1 is missing because it's either in front of Jupiter or it's behind Jupiter. And if you look there long enough, you'll start to see them. Ones, especially Io, will be right, if it's right beside Jupiter, you can just sit there and you can watch it going behind. It's the movement of objects in space that's really fascinates me. It's not all static. Jupiter has about 74 moons, but they're always finding more, so I'm not going to, don't quote me on any statistics. This is a picture taken by one of the members of our club. We've got some really extraordinary astrophotographers. And this is one he took in the summer, and I grabbed and I put on our Facebook page. If you go on our Facebook page, we have about 50 photographs we've taken since June, and a lot of them are of the comet that was over here. And this is what he took of Jupiter. And he just did it through a handheld camera on a tripod linked to a computer, and then he processed it. But this is the moon Io, which I said is the smallest of the big 4. And about 100 times a year, we catch a moon passing in front of Jupiter. It's called a transit. And if you notice that Io is the same color as Jupiter, so you don't actually see Io, the moon, crossing the orbit, but you see its shadow. And it's called a shadow transit. And it takes about 2 hours to cross. And you can go on anywhere on the internet and find a schedule because they've got it down to the minute. And you get out there and you observe it and you see the moon coming along, comes along, then disappears. And about 20 minutes later, you pick up the shadow coming across. And it crosses and crosses and crosses and crosses. It takes about 2 hours, I said. And then about here, the moon shows up again. And then about 20 minutes later, the shadow disappears. And it's just this idea that you're looking at things moving in space. So it's not static. And I like everything that moves in space. One night I was out observing, and I was looking at Ganymede, and Ganymede puts out a big shadow. Io, sometimes the shadow follows this band here, and it plays hide and seek in here. It's difficult to see, but Ganymede comes across here because it's fairly big. And one night I got halfway across, and around the corner here came the great red spot, and they started to race each other across the planet. And I'm like, yay, go for it! People are, what is wrong with this guy? Which is cool. It's kind of hard to explain to people, and it's better just to be crazy. There are double transits, and about once or twice a year you'll get triple transit. But you're up anytime it's dark, you could be doing this. So you could start with a double transit. I think the last one I did started at 5 minutes to midnight, and it ended at 2 o'clock. And the second shadow started at 1 o'clock and went to 3 o'clock. And so it's just extraordinary to watch that. And I just like doing it. It's not hard to do. It just takes patience and the right optics to do it. I can do it with my telescope. And it's not a very powerful telescope, and it doesn't require a lot of magnification. It just requires a clear night and some patience. I've got you on Saturn. Yeah, Saturn looks like this. The rings are real. Even in a small telescope, one can see some of Saturn's moons, and they don't go around in a line. They go around in a big circle around. The easiest one to spot is Titan, and because it's the largest moon in our solar system. But that's not the way you'd see it in a telescope. But I'm going to show you something. Can everybody see my pointer here? When you go and look at Saturn through a lens, if you can see this shadow line between the rings and the planet itself, it tricks your eyes into seeing 3D. And instead of looking at this as a circle, you actually see it as a sphere. It's just a brain, what your brain starts to see, because it believes that it's looking at this and it's giving depth and form to the actual circle. That's just from the shadow. So when you're looking through, I tell people this when they're using the telescope and they see it, because they say, "Oh wow." This is what you would see if you had a lot of magnification. I don't put a lot of magnification on, because if you do, the Earth moves fairly quickly, and instead of taking 5 minutes to go across your field of view, if you put off enough magnification to really, really see all the detail, it takes about 2 minutes to cross. And my telescope is manual, so you're not good enough. I'm not good enough to track it that way. There's Titan. And the other moons are around here. And you'll be able to see this when I show you the Planetarium program. But that's Saturn, and it is extraordinary. It's one of those moments. I remember 2 years ago, I went back to York University, and I went to the observatory there, and I walked into the room. But before I walked into the room, I knew where exactly everything was, because 31 years ago, I'd walked in there and I'd seen Saturn. And so not only did I burn it into my brain about how wonderful Saturn was, but I remembered my entire surroundings during that time. So that's what I mean. This is what's extraordinary about, this is why I like astronomy. Neptune, number 5. It's an extraordinary color blue. And this is not the actual color I see it as. With a dark sky and a big telescope, actually you can see it through my telescope, but it's a pain in the ass to find. But with a dark sky and a big telescope, the planet is an amazing color blue. I'll just show you a color that I think is as close as I can get, but you don't see this. The darker the moon, let's see. The photos don't do it justice. One needs a dark sky to really know where to look to spot it. But you should be able to find it when I show you this. All right, now I'm going to give you your first lesson in astronomy, and this is what I teach at star parties, because I'm not good for anything else. It's called the ecliptic, or the path of the sun, or the path of the planets. Now, I just found this graphic a couple of days ago, and I'm kind of neat because I talk with my hands, and the way I explain it is this. When you draw a picture of the solar system on a piece of paper, you have the piece of paper, everybody see my hand here? And you draw all the planets in circles on the piece of paper. Well, that's true, because the planets don't fly around like this. They're all in that line, they're all in the same plane. If you hold up the piece of paper, along that line will all the planets in the solar system will pass. So what I'm going to do is, I'm just going to check out here. I'm going to take you to a program, free, and it's on the information sheet. I suggest you get it, because it's a really good thing to play around with. It's called Stellarium, and it's what I use to find my way around the sky. It's just opening up now. It's free, it's downloadable. This is Stellarium, it's a planetarium program. There's also Sky Safari you can get for your home, for your smartphone. And what this does is it gives you a planet, it gives you the night sky or day sky or whatever you want. You just put it, when you download it into your computer, you tell it where you are, and it will automatically start tracking the sky for you. So whenever you come onto it, you'll be able to see it. So there's east, we're looking south, and there's west. So the sun is setting in the west, which is just about now. Yeah, I'm looking at the sun now. If only damn cloud. Oh, if anybody finds a way to move clouds out of the way, could you contact me? Because if it works, I'll get you the Nobel Prize and the enmity of every and the friendship of every astronomer in the world. If you want, I mean, whatever. Now we're going to go back 2 months when the planets were more friendly, and we're going to go to a darker sky. Now, can everybody see this? All right. What I've done is I've brought up. Let me just zoom back here. Okay, that's the path. This red line is the path of the sun. So it rises in the east, travels across the sky, and sets in the west. It's a little off because the seasons are changing. But if we were at the equator, it will go directly over us. But since we're 43 degrees from the equator here, on their way to the north, we look out about 43 degrees to the south, and we should see a line. And on that line is the plane of the solar system. So we look at the west, we see the moon is setting. Let me just go back a bit here. I wish I could do this in real life. Come back here, there. So there's the moon, and it's setting. But remember what I said about looking for the terminator? Gosh, this graphic is good. But this is along here is where you would be looking for any of the features to learn what the moon's all about. Now it's the angle between us and the moon is a little different for each planet, and that's why it's not exactly on the ecliptic. But in about an hour, it will have set. Right behind it, we have Jupiter and Saturn. And did anybody pick this up in the news recently about a conjunction in December? Well, what it is Saturn has been getting closer and closer to Jupiter. And right now, 2 months later, it's down about here. So it's already past Jupiter. And they haven't changed. It's just the angle between us as we go around the sun. The angle changes. Jupiter and Saturn are still far enough apart from each other. They don't even affect each other. Now, our friend Mars has been coming up since April, and it's about directly over us right now. And halfway between Saturn and Jupiter, halfway between Saturn and Mars, we'll zoom in here and I'll show you something. There's Neptune. And this is the truest color I can find for what Neptune looks like. And that's what I like to see through a telescope. What an extraordinary color, eh? It really is that bright. Uranus is brown. Well, it's tan color, so it's not as sexy, but this is what you'd see in about a 17-inch telescope. And there's his largest moon, Triton. And I love this program because if you can zoom right in, it'll give you lots of detail. And so you can really get in, and I've been using this for about 8 years, and the updates are getting better and better. Like this graphic wasn't as good 8 years ago, but it's quite good now. But yeah, that's what you would see. If you were looking through my telescope, you'd probably see this. But if you're looking through a larger telescope with more magnification, you'd see this. Well, more like this. But you would see the color. It's a gas planet, so it's quite, there's no detail to it. Okay, then there's Mars, and that's kind of boring. Yeah, if you get we have some really good photographers on Mars, and we had one guy, he got, in April, the polar ice cap was melting, and it was gone by May. But the southern polar ice cap, if you get a good night and it's clear and you get a good enough telescope, you can see the southern polar ice cap because that's actually permanent. One year I was really getting into looking for Mars, and a dust storm started on the entire planet. So I didn't get to see anything for about 6 months. Kind of boring. Basically, just beyond, following Mars for the last 8 months is Uranus. And this one you can't see from the city, and you really have to be good at what you're doing, or you have to have a motorized telescope to actually see it. But this is Uranus. So just in that one part of the sky, this is what I've been doing outside my day job for the last 6 months. We've got 1, 2, 3, 4, 5, and 6 planets all in the same field of view, all in the evening. And you guys missed it. So right now, Jupiter and Saturn have set below the horizon, and they'll be coming up in the morning sky in March. But you have to be up really early for that. So yeah, I guess you're SOL for a couple months anyway. But you should have met. It's too bad you missed it. But people want to hide these days. So now what we can do is we can advance the time. Now the 2 planets closest to the sun are Venus and Mercury. And if they're on the right side of the sun, as you look at it, they'll show up in the morning. If they're on the left side, they'll show up in the evening after the sun sets. So that's why the Venus was called the morning star and the evening star. And they actually have phases to them the same way the moon does, but all the other planets, they don't because they're away from the sun. Now here's something that's interesting. It's called the Pleiades. Anybody ever heard of it? With binoculars, it's a group of 7 stars, and it's quite extraordinary to see. It's just an object that's worth seeing. Does anybody know what it's called in Japan? It's called Subaru. You look at the Subaru logo on the cars, they've got 7 stars. So there's some trivia that'll get you kicked out of every social function you go to. So we're going to advance the clock to about 6 o'clock in the morning. And we should be seeing, yeah, it should be just before the sun comes up. There's Venus and Mercury. So if you know where to look with a pair of binoculars, with just your naked eye, you should be able to see all the planets except for Neptune and Uranus. And all you need is a small telescope to see Neptune and Uranus. So this will tell you exactly where you are. Now, if you go out in the morning, all you have to do is click on this, and it will tell you all the information you need to find this. And what I do is I will look at the time, and it will tell me what time it is, which is 6:40:24 in the morning on this date. And then I go out with a compass and I look at the azimuth and the altitude, and I set the compass for 123 degrees, and I look 19 degrees above the horizon, and Venus will be there. So this is as complicated as you'll want. All this other data is just data on where everything is on its current position. But does anybody have any questions on the ecliptic? It's quite an extraordinary thing to learn. And if you know that, then you can go outside, and if you know where the sun is, you know where the ecliptic is, and you'll now know where to look for planets. And of course, if you use Stellarium, you'll go out and you look like a genius because everybody going, "What's that?" And you go, "That's Jupiter." And you go, "How do you know that?" "Well, I know this much more than you do, so I'm a genius." I do this all the time. Now, there's something I want to show you, and this is another thing. I'm against astrology, but there's something that's really neat here. Let's see. Constellations. All right. Let's see, labels. They're all in rectangles of various shapes. There's very narrow rectangles, there's great big square rectangles and stuff like that. But they're all named for something, and there are 88 of them, and they divide up the entire sky. 33 of them will not be on the test at the end of this because they're in the southern hemisphere. And unless you go down there for at least a week, you won't be able to see them. Of course, I have because I'm being smug. But they're all named by things you've all known the name, and you know the names of 12 of them, and I can show you how to find 14 of them. And I'm just going to go back in time a bit because I like doing that. If you look at the ecliptic, the constellations that touch the ecliptic are the signs of the zodiac. So you've got Virgo here, Leo, Cancer, Gemini, Taurus, and down here is Pisces. And the rest of them are all in that big circle. Now, 12 of the names are published in the newspaper every day, and they're wrong because there's a 13th constellation of the zodiac. So does anybody have a birthday between the 18th of November and about the 12th of December? Then you're no longer a Sagittarian. You're an Ophiucan. And whenever somebody, I'm a Taurus, but when anybody asks me what I am, I say I'm an Ophiucan, and they go, that can't be right. I said, yeah, you're 2,000 years out of date. But that's how they determine where the signs of the zodiac. So that just gives you an idea of how to find your way around the sky. Once you discover where the sun is, you'll know where the ecliptic is. You'll be able to look on here and find out what part of the sky is visible right now. And then you start going, and if you're looking for something in particular, like Ursa Major here, which is the Big Bear, you'll know how to find it by finding stars closest to the ecliptic, and then you go up to it. Like I said, I love it. Because it's simple to use. All you have to do is put it in your location. Now there's something else here that I really like. Just go through the menu. It's fairly simple. There's no math to it or anything. It's just you just take a little bit of knowledge that you have, and you can go in here and find out what you want. So you can in the sky you can put all sorts of different galactic grids and all these coordinates that I never use. You can use projections and all these other things that I never use. I just stay with the basics. But there's something up here called star lore. And let's go to, they've got all these cultures and all their star patterns. So you've got Aztec and Arabian and Korean and Chinese. And there's one here I particularly like, is Innu. And what that does is it gives you the constellations for the Inuit. Let me see, I have to do this again, right? And there they are. And they don't use the same constellations we do. There's one here called the Old Man. The only one we know about that can recognize is this is the Big Dipper. What's really interesting is the Big Dipper is almost a universal constellation for the universe. The Chinese call it the horse. The Europeans, the English call it the plow. It's called the horse and cart in other places. And so it's quite extraordinary if you go in here and just see what it's all about. And I don't know what this, they're collarbones, I don't know. But it relates to how they, spirit of the polar bear. I'm just reading this right now. The blubber container or lamp sand. So they're just using particular stars, and they've ignored other things that we use. And in Aboriginal culture, they don't even use stars because there are large, in the Southern Hemisphere, there are large areas like here that are just dark areas of the sky caused by clouds of gas. And so they have one down there that's shaped like a crane, like a heron flight. And so just go in here and poke around and see what you can learn, and you'll have some trivia to get you kicked out of every cocktail party from now until. Okay, I'm going to go back to changing this to. Okay, where are we now? We're at the ecliptic. All right, enough of that. Anybody have any problems with the ecliptic? All right, now you should be able to teach this. But it's really, it's simple concepts, but they're amazing when you can show somebody the sky and they go, wow. And I go, gotcha. You're mine now. Okay, next thing is not comet Neowise. This is a picture taken of comet Neowise. Like I said, it was the second best comet I've ever seen in my life. And it showed up around April and it ran till about July. And I'm showing you this because we've took about 50 pictures of it. They're all posted on our Facebook. If you don't have Facebook, you can go on to the our website, click on the link to our Facebook page, and then you can go and see what we're doing there. Let's see. I call this piloting Earth through space because a comet, when it comes in, there are about 4,000, at any time, there are about 4,000 comets in the solar system. And we have a comet lady in the club. She's been in astronomy for about 60 years. And she's doing comets now. And she does comet update at most of our meetings. And so there's always comets coming in. There are always comets going out, and there are always comets dying in the surface of the sun. There's comets exploding all over the place. Some only last a short time before disappearing. The passage of most are never noticed, but occasionally a comet becomes immortal. And this is comet Neowise, and we saw it coming in. Actually, the comet lady told us comet Atlas was the big one, and we got all excited about that. And then she broke her heart when she said, "Oh, it's just exploded and destroyed itself." And we went, "Ah!" So around June, she said Neowise is coming. And of course, by this time, once you've been kissed, you don't want to have this happen again, right? And somebody woke up one morning and said, "It hasn't broken up yet." So all of a sudden, we're out there at 4 a.m, we're running around looking at the sky. And then it eventually started coming up in the evening sky. And then about the end of July, it went away. But what it does is it's a streak, it's an icy snowball. And it's a dirty snowball, and it leaves a trail of ice crystals behind it. Well, that's not uncommon. This just eventually blows away and stuff like this. But over the course of time, 10 of these comet tails have wound up sitting in the orbit of the Earth. So 10 times a year, the Earth passes through the tail of a comet. And these particles coming in are about the size of a grain of sand. And when they hit the Earth, they're hitting it at about 50,000 kilometers an hour. And that's why you see a streak of light in the sky. It's about 2 meters wide and about 50 kilometers long, and it lasts about 2 or 3 seconds. If it's made of ice, it'll do that. If it's made of rock, it converts much more energy, and it basically explodes. And that's where you get to fireballs as opposed to just streaks of light. And 10 times a year, we have meteor showers. And this is what a meteor shower looks like if you could stop time. So the biggest meteor shower, the most active meteor shower we have in the year is the Perseids on August the 12th. And they come in at about 100 to 120 an hour if you have a good year. And like everything in 2020, the Perseids for 2020 sucked. I think I saw 2 per hour, and then I got fed up and went home. And I was in a dark sky. So if you can imagine, if you get enough of them coming in, that you actually get that star field effect, because they're coming towards you, right, from one spot in the sky. So it's like the Star Trek thing. It's just coming towards you, and you see these streaks going past, right? If you get enough of them, you get a sense of motion, kind of neat. And if you stand there and think, your brain will start to think that you're flying through space. And what's really neat is you are, because it's the Earth passing through the tail of the comet. And there have been times I have stood there watching meteors streaking in and felt my hand clenching an imaginary joystick as I piloted our planet through the heavens. It was a moment in my life. And some people go out and chase all over the world looking for total eclipses. I go out chasing this. So every year I'm at the mercy of the Perseids, and I want to get that thrill because it's amazing. I did this at a star party 2 years ago, and the science outreach person from the University of Waterloo, like we had 300 people there, and the science outreach person from the University of Waterloo came up really excited and said, Jim, you freaked those girls out. And I went, oh my God, I'm in the dark of freaking women out. Oh, I shouldn't be doing this. She said, what it was you just told her what I just told you, which was you're piloting planet Earth through this universe. And they went away. About 20 minutes later, it clicked into their head and they had the, oh my God moment. That's when they freaked out. And I went, that's a success for me. If I can make somebody think that, they understand there's something in the universe they can look up. Anybody get thrilled with that? That's neat, isn't it? Well, it's just that moment I'm trying to tell people about. One of the reasons why I want to follow Perseverance when it lands on Mars is it won't be doing geology. It has 3 missions. One is to prepare samples for a sample return mission. One is to search for signs of ancient life. So burrowing in the rocks, looking for anything really that they could say was life at one time. And the third thing is prepare the planet for humans. All Curiosity is doing right now is running around banging on rocks, looking for minerals and doing geology. I think Perseverance is going to be it's a much more dynamic mission. Plus they're taking a helicopter and they're taking a small laboratory that is trying to convert the CO2 in the atmosphere into oxygen. So yeah, they are preparing for life, and the sooner we go, the better. But what's really interesting, remember the ecliptic on the stellarium? If we could see the asteroids, they would be on that line. You would be a continuous line of rocks all the way around the Earth in our orbit. But mining and stuff like that, you followed the Hubble mission that just came back from taking a sample of an asteroid. Okay, they came back. They actually brought asteroid dust back. And now they're going to go through the boring phases where they're going to write up all the reports and what they saw and what they found. And it's going to be boring because they just brought back some dirt. But it's really expensive dirt, so really cool. But I follow a lot of things, but you can get right into too many things. But as far as aliens go, I certainly hope so. But there's no proof either way. And I'm perfectly willing to go with, I don't know. It's like what you ask, like every once in a while, we'll get a professional astronomer to come in and talk about dark matter. And at the end of the lecture, we just go, so you really don't know what it is? He says, we still don't have any idea what it is. When they say, well, our universe is only 13.8 billion light years across, it's, no, it isn't, because what's beyond it? More space. So anyway, that's the story about the meteor shower. If we do like to put an event on in August, and for the Perseids, we normally run about 300 people at the University of Waterloo. I want to do 1,000. I want to stop traffic for the entire northern part of Waterloo while they look at the meteorites. And that pisses the people off at University of Waterloo because they just want to have an event they can write up. And I'd say, no, we've got to stop the city. And no, get away from me, John. So my delusions of grandeur, but I might actually pull it off one day. And if I ever get arrested for causing havoc because of a star party, I'll just tell the cops, if you arrest me, I'll have 2,000 people here next year. And if I go to trial, there'll be 5,000. So, and they'll probably go, Jim, okay, you can go home. Anyway, so I have delusions of grandeur because we're talking about the grandest thing in our lives, which is the universe. Anyway, anybody have any questions about piloting the Earth through space? Anybody want to do it? It's just, you have to work at it. You have to get out there a lot to do it, and it may take you 10 years before it eventually happens, but you can do it anywhere. Okay, I'll talk about the Hubble Deep Field. Does anybody know about this? Oh, I'm really disappointed. This is one of the most extraordinary things in the history of humanity, and you guys went, whatever. Okay, what it was is in 1995, a couple of years after they finally sorted out the problem with the Hubble Space Telescope, they started taking pictures of all sorts of things, of galaxies and stars and all this sort of stuff. And then the director of the Hubble Space Telescope says, well, why don't we point it at a really dark place where we don't believe there's anything? And everybody, it costs us $2 billion a year to run this damn thing, and you want to point it to nothing. He says, yeah, I want to do it for 10 straight days. He went, so, but since he was the boss, he got to do what he did. So what he did was, this is the Earth, this is the orbit, Hubble is in orbit. He wanted to look at a spot high enough that you could have the Hubble Space Telescope point at this spot for 10 straight days. And they wanted to take it at a dark spot away from our Milky Way and any other bright areas in the universe. And they settled on a spot just above the Big Dipper, and they collected photons from a field of view no wider than a head of a pin held at the end of your arm. So a really, really, really small section of the sky, 2.3 arc seconds, which is, I think it's an arc second is a 60th or 100th of a minute. And it takes 60 minutes to make a degree, and it takes 360 degrees to make a circle. So why they're still using degrees, I don't know, but I'd rather use mils, which are based on the decimal system. Anyway, and all they did was collect photons for 10 straight days. They took 342 images, and then they put them through a computer. They got rid of all the differences, and this is what they come up with. I don't know why it isn't a square or a circle, but this is what they came up with. There are 3,000 galaxies in this dark spot of the sky. There are a few stars here and here, but the rest of these are galaxies. And that's in the darkest part of the sky we could find. Now, what's extraordinary about this is, look, a telescope is a time machine. So when you're looking at the sun, you're looking 8 minutes back into time. When you're looking at Neptune, you're looking about 2 hours back in time, because that's how long the light gets to get here. What you're looking at here is 12 billion years back into time. And it's the equivalent of standing here, pointing a telescope far enough back into time that you see people building the pyramids. And then in the background behind that, you see a Neanderthal walking around. Because these things, the original galaxies and the Neanderthals are all gone. But the image of them are still, for the light reflected off them is still heading towards us. So beyond the Neanderthal, you can see in the distance the dinosaurs. And that's only going back 70 million years. This is going back 12 billion years. So in the beginning, after the Big Bang, in the first billion years or so, small galaxies started to form, and they eventually just died, and the matter was formed into other galaxies, and then they died, and then other galaxies. So we're basically the second or third generation of galaxies beyond the Big Bang. But all of them, the new galaxies, the middle galaxies, and the proto-galaxies, or the original galaxies, are in this picture. Isn't that extraordinary? Now, what they also did, because scientists just can't leave anything alone, is they said, well, that may have been a one-off. So what they did was 2 years later, with better optics, because they improved they changed the optics package in the Hubble Space Telescope, I think 3 times. So 2 years later, when they changed it again, they pointed it at someplace, a dark spot in the southern hemisphere, and they took a picture. And you should see that picture. It's called Hubble Deep Field South. And then they improved it again, and their techniques got better, and they were able to image better and stuff like this. And they came up with the Hubble Ultra Deep Field. And I remember when they released it, they said it's 3 terabytes of information. If you printed it out, it would take up the largest wall inside your house. as a poster, and it would just be all of this, as dense as that. And it's supposed to be the most profound photograph ever taken in human history. So look it up. It's on Wikipedia. It'll give you some idea of it. And then you can go on NASA's site and download it all if you want. And of course, they went to a Hubble extreme deep field. But then by then, of course, I've got the points, so I don't have to go on with their extreme thing and anything like that. But these are things that are astounding. And this is one of the most amazing things. If you actually understand, you're looking back 12 billion years. The Hubble ultra deep field, not the Hubble extreme deep field, the Hubble ultra deep field goes back 47 billion years. And there's a way to explain that, how you count, because our universe is supposed to be only 13.8 billion years old. How can you get 47 billion years ago? Well, look it up, because I'm not going to explain it to you. Anybody have any questions about this photograph? No? Well, you should know enough to ask questions. And that's all I'm doing. I'm giving you enough information. And because I understand that you didn't ask me any questions, very many questions, because you don't know very much. Now your wheels are starting to burn, the lamp is starting to burn in your head, and you're starting to recall stuff you've heard and things you've seen. And now it's just going to grow on you, and you're going to take a little bit at a time. Don't think you're going to remember all of this. I can send you the transcript of this if you want, and I can send you the PowerPoint presentation, but really, you're now more aware of what's going on, and you'll be more sensitive when you be more sensitive to hearing things in the news. And so you'll be sitting there and with your family, and the news will come on about Perseverance is just about to land, and you go, yeah, well, it's the 18th. It's going to be landing tomorrow. It's going to be going down here. And they're going, what are you? Where did you get that? And you're going, well, and you don't have to tell them. But if you put your, if you just say, well, Jim told me, they'll go, oh Christ, not him. Because this is one of my most interesting things. It's just great, and that leads me into the 9th thing I find about it exciting: the news. We live in extraordinary times. And I think it's incumbent on us to tell people things are happening other than all the negativity you hear. We live in amazing times. There are discoveries announced every day. Right now, in July, we launched 4 missions to Mars. There's the United Arab Emirates is sending a probe to examine the atmosphere in the Martian atmosphere that'll give us a more detailed examination of it. The Chinese are going with their first lander and orbiter. And who's the other one? Anyway, forget about it. This is Perseverance. It looks like Curiosity because it's made out of a lot of the same parts as Curiosity, the nuclear-powered robot, the rover that's roving on Mars. Our club had a talk by one of the university professors, Wolf, who actually worked on one of the sensors that's on its way to Mars right now. And he was talking to the club last month. What was it, month? First of the month. Yeah, okay. And so these are the type of, the good thing about Zoom calls, you don't have to pay their way to come to your meeting. You can just get them to talk on Zoom for an hour. So this is the spacecraft assembly room at Jet Propulsion Laboratory. And I went there in 2009, I actually saw it being built. So this is what I'm giving a talk about it on Friday. The mission patches up here are all the spacecraft they've built. So all the spacecraft like Voyager, Pioneer, Viking, all the landers on Mars, except for Beagles, because that crashed. All the deep space missions are all run out of Jet Propulsion Laboratory. And to me, these are the guys that are the real space program. The manned spacecraft program hasn't gone beyond the moon. These guys are out of the solar system right now, and they're still talking to them 30 or 40 years later. So these guys do quality work. And this is the one that's taking the helicopter, the oxygen lab, and performing those 3 other missions. And anyway, so it's an extraordinary machine. It lands, it does its landing on the 18th of February. This is strictly NASA. University of California under contract with NASA. They've been putting probes and spacecraft into space for 50 years. Okay, so this is one of the stories you should be following. The United Arab Emirates is sending a mission they call HOPE, and it's going to give a detailed examination of the atmosphere of Mars in a way that hasn't been done before. There have been almost 50 missions gone to Mars. All the Russian missions have failed. So for a long time, there was a 50% failure rate on every mission they sent to Mars. The Russians were 100%. And it was Jet Propulsion Laboratory that actually had the most success. And it's only now that people are catching up. The only other lander that was directed at Mars came out of the Europeans. They called it the Beagle. And one of the NASA missions eventually found what was left when after it had smashed into the surface, and it's pulverized. And it's want anything done right, get JPL to do it. These guys are so good at it. They're experts at it. These guys are the space program as far as I'm concerned. And this year they might actually get the James Webb Space Telescope up. This is an infrared telescope that's supposed to be replacing Hubble. And it's going to be much more capable, but it was supposed to launch in 2004. In 2016, I started becoming cheerleader for them. And every year I do a talk on it and embarrass myself when they say, oh, well, they'll cancel it again for another year. It's supposed to be going up this year, but then I've been kissed before, so we'll see. I think what happens is if they stick with the original program, well, the thing is, it's cutting edge stuff, right? It's technology and there's never been done before. If you understood the Galileo program that studied Jupiter, you'd understand the bureaucracy and how everything gets screwed up in the back and everything like this. And that mission ran for 25 years before it finally plunged into Jupiter. So this one, it's a one-off. If it doesn't work, it's complicated. If it doesn't work, there's no way to fix it. So they're double checking, triple checking, but the thing is, they're just one thing leads to one other delay and one other delay, and then. But there's never been any problem with it being canceled. It's a go. It's just it has to work perfectly, otherwise they'll be very embarrassed. But I'm just tired of waiting for it. That's all. They should have put Elon Musk on it. He would have had it up 10 years ago and it would have been already finished and he would already had 5 replacements for it. And the number 10 reason why I like astronomy is because you hang around with people who know a lot of things. You can't know everything in astronomy. And when I first did my first presentation in the Astronomy Club, there were people in the room that had been in astronomy for 40 years. So I just picked a subject that I knew and they didn't. And at the end, they said, oh, I learned something from that. So everybody can contribute and everybody sits around and everybody comes at it from different ways. And these guys sitting around, what we were looking at that night was a double transit on Jupiter. And I didn't even take my telescope out of the car because I was sponging off everybody else. Because if they've got better telescopes, why not? I'm not very good at finding a galaxy or a star clusters or the Horsehead Nebula. I once, after a lot of coaching, found the Ring Nebula, which was good. Finding my 2 favorite galaxies, which is M81 and M82, are still a challenge. But I hang around people who really know the night sky, and they're always showing me stuff up there. In astronomy, you can't know everything. So do like I do and sponge off people. They're always happy to show you. This is our private dark sky site. It's invitation, members only, but it's the only thing that in our club that we don't allow the public to go to unless you go by invite, which is you know somebody, we'll take you there. It's not, but it's a good dark sky site. And it's one of the benefits of being a member. Anybody have any questions on the 10 things I like about astronomy? In 2009 was the 400th anniversary of Galileo's first looking up at the heavens with a telescope. I bought a replica telescope. It has the same same lenses as the original Galileo telescope, so you're able to look through it and see Jupiter the way Galileo would have seen it. And it cost me $30. And then I was one day mooching around the science outreach people in the University of Waterloo, because I do that. I'm always on the scrounge for something. And she took me down to the secret underground, in the basement, in the back, behind the rats, warehouse they have down there. And she gave me 4 of them. So I said, I paid $30 for one. You give me 4 of them. So I gave them out to the members. But the telescope I have is actually a rental from the club. I've been using it for 6 years, and nobody has the nerve to ask for it back. And besides, I'm beating it up all the time. But the best telescope is one that's used. Like these guys will take, like his telescopes in the back there take a long time to set up. Mine takes 10 seconds. So I use it a lot. And I use it a lot more than these guys use it. So the best telescope is one that's used. And they're good at what they do, and I'm good at what I do. And we complement each other, and that's what you want. You want differences. You want a lot of diverse thought, and because everybody in the club can teach you something. Everybody's good at something. And even the newest person always comes up with some sort of idea from out left field, and you just go, well, I have to think about that. And I'm always perfectly willing to spout off something that sounds absolutely ridiculous. And I will usually get a really good answer back. And it's a good way to learn if you're just a little bit humble with it. But yeah, it's fun. It really is. Now, anybody have any questions? Look at the other things like, I didn't even show you any galaxies. I didn't show you any star clusters or anything like that. Look up M81. And what's really interesting about M81 is the galaxy that's sitting like this is flat on. And right beside it is M82, and it's called the cigar galaxy, and it sits like this. It's in the same field of view in your telescope. So you see 2 galaxies like this, and that's why I like those galaxies, because they're easy to find. And you can just find them just type them in the search in Stellarium, and they'll come up and they'll show you things. And just poke around and learn all about this. And there's no math in it. It's just fun. Just poke around and get your kids on it and just have them look around at it. Now, this is something that Neil deGrasse Tyson, I like his quote. When stars exploded, the universe mostly started with hydrogen. And when a star gets so old it explodes, during that explosion, it creates all the elements in our periodic table. So basically, everything that you are came from exploding stars. And this is his most profound thoughts. All the elements in the universe were created in an explosion of stars. We're not just in the universe. The universe is in all of us. And I do a lot of hiking, long distances. Like I've walked across 6 countries. And what's most extraordinary is when you're on there, you invent yourself a trail name, and mine is Transient. And besides just being a bum walking down a dirt trail for months at a time, I also look at it as, I just started as a bunch of atoms in the universe, and I coalesced into being me. And one day, all those atoms will go back to the universe. So for a brief moment in time, I'm just transiting through the universe as I am now. Too profound? Anyway, that's just a side note, okay? So basically, that's where we all come from. That's where we're all going. average lifespan of a molecule of water is 60 million years. It adds and divides itself about 2,000 times a second. But over the course, if you put it in a container, sealed container, it would stay that way for at least 60 million years. So when you drink a glass of water, how much memory does it have of it actually passing through? How much memory does that water actually have of it passing through your body? It's insignificant in 60 million year lifespan. So enjoy your time where you're here. Carl Sagan, he said, life is but momentary glimpse of the outstanding universe. And astronomy is a passion of mine. It's full of galaxies and nebula and dark forces we know nothing about and fantastical things we're only beginning to imagine. We've gone so far beyond what we knew growing up. Our children are used to hearing unpleasant things every day. It would be good for them to know what a remarkable time today is. To me, astronomy is all about moments of discovery. It shows us how wondrous our lives are to be part of it. My real passion is the opportunity to introduce the universe to people so that they really see it for the first time. Thanks for giving me the opportunity tonight.